Hello everyone, this is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please, before we go into today's topic, kindly help me to like, share, subscribe to my video so that you can have more of my videos. Thank you so much and God bless. Today we are taking mathematics, and the topic we are taking under mathematics is polynomial. So we are starting. Now, when I talk about polynomial, generally we talk about a function. That's function f of x. We talk about function f of x. It's given as summation of coefficients times the variable x. This coefficient has a counter. So the counter is n, then power n. Then the counter starts from 0 and end in infinity. Now, this n that we have here is called power. It's called power or the degree of the polynomial. So the n I have here is just counter because of the position of that letter n. It's a counter. Then this symbol that I have here has a name. The name is called sigma, and sigma simply means summation. So what are this particular symbol? It's called sigma, and in mathematics it actually means summation. That means we are going to sum the terms that we are having in there. Now, if I'm starting from 0, that means when my n is 0, I put it here. So my function f of x now, my function f of x as n is equal to 0, I'm going to have 0 x raised to the power 0. Then I move down to when n is 1. I'm going to be counting from 0, 1, 2, 3, and so on and so forth. So that is plus c1 x raised to the power 1, then plus c2 x raised to the power 2, plus, and it will continue like that until, but let me continue the summation. X raised to the power 3 plus x raised to the power 4. So it will continue up to, if you look at this pattern now, if I have n below, I will have x raised to the power n. So this expression that I have here, in mathematics, any parameter that is raised to power 0 actually gives us 1 as our answer. So this x raised to the power 0 is actually 1. So what I'm going to do now is to rewrite this function in this format. I will have f of x now can be written as this, then times 1, that's that, then plus c1 x raised to the power 1, then plus c2 x raised to the power 2, plus c3 x raised to the power 3, plus this is supposed to be c4, that's c4 x raised to the power 4. Then it will continue, the addition continues up to when I have cn x raised to the power n. So each of these parts of the whole polynomial is known as term. It's known as term. So polynomial is simply summation of terms in variable x. This particular parameter that I have here is known as independent variable. This x that I have here is known as independent variable. It's not an independent variable. So and then the f of x is known as dependent variable. While what I have here inside is called independent variable. Please take note of that. Another way to write f of x is to write it as y. Now, this expression that I have here, if I have only one expression, I'm bringing it out one by one. If I have f of x and I have this one alone, this is called constant function. And it has only one term, because I said each of these is term. That is term. So constant function. Because it has only one term, it can be called monomial. Monomial. The word mono simply means one. So that means it has one term. Now, if I pick this and this, I'm having two times. If my f of x, I'm picking this constant term, then I pick this one, plus c1x. The highest power of this variable is 1. And then because I'm having two terms here, this is known as binomial. It's known as binomial. So bi simply in science, bi means 2. So that means this one has two times, t1 and t2. This binomial that I have here is also known as a linear equation. Linear in the sense that if I take this c0 as my c, plus this c1, if I take it as a gradient of this variable x on a graph, then this is similar to the normal straight line graph. So this one, this number 1, this case number 2. This case number 2, I call it linear function. Linear function. The reason why it is called linear is that if you plot the graph of this function, it's going to give you a straight line graph. That's why it is called linear, from the word line, linear. So if you plot this one, it will give you a straight line graph. So, and it is a linear function, what I have, this second one. Then, if I pick 3 times, I pick this, and this 3 times, I will have f of x is equal to c0 plus c1x plus c2 x raised to the power 2. I'm having first term, second term, and third term. So I'm having 3 terms. From the word in science, tri simply means 3. So this one can be called trinomial. Trinomial. And this one can be written in a format that we can easily understand. This c0, if I take it as c, plus if c1, I take it as b, I have bx. Then if I take this c2 as a, I have a x raised to the power 2. So this is what we are familiar with most of the time in mathematics. So I can rearrange. I have it as a squared plus bx plus c. So this trinomial is also known as quadratic function. Quadratic function. Please take note of that. Quadratic function. I believe that you have noted what I have here on the board. I want to continue by creating space. Let's go to the next polynomial. Now, if I take 1, 2, 3, 4, I have f of x in this case as a c0 plus c1x plus c2x squared plus c3x cubed. Now, this, because I'm having cube here, this is known as cubic function. Cubic function. The highest power of this cubic function is 3. So if I rearrange this one, I can equally, rearrange it as a c3 x raised to the power 3 plus c2 x raised to the power 2 plus c1x, then plus c0. And you can easily see the beauty of this expression that I have here by taking c3 to be letter a, x raised to the power 3, then this one to be letter b, x raised to the power 2, then this one to be letter c, s, then this one to be letter d. You can see that you can easily recognize this particular function that I have here. So, and then when I talk about polynomial, the word poly, this one is an example of polynomial. The word poly means many. Polynomial. That means nomia simply means name. Poly means many name. Poly means many. Many. So when I say polynomial, arbitrarily, it actually means many name. Many names. Like when we talk about polytechnics, we mean many techniques. A place where many techniques are being studied to be able to solve societal problems. So the same thing with this polynomial. So a polynomial, by definition, with what I have here now, this particular polynomial is the expression of the sum of variable x in terms of either ascending power of that variable x or descending power. Like what I have here now. If you look at this power, the power is decreasing the way I arrange it. So this is the arrangement in decreasing power of a variable x. If you look at this place now, you can see that it's a decreasing power of a variable x. If you look at this place, you can see that the power of variable x is increasing. I rearrange this one, I put this one in form of increasing power of variable x, and this one as a decreasing power of variable x. So polynomial is simply the summation of different terms that involve variable that involve a single variable, such as variable x. Our variable can be any this thing in science, can be any letter. You can use letter y, you can use letter k, and so on and so, depending on the idea of the idea you are trying to project. So this one now that I have here, I'm going to convert this polynomial expression to what is known as Maclaurin series in mathematics. From Maclaurin series, we are going to go to what is called Taylor series. So I want to generate Maclaurin series using this polynomial expression. Now what I'm going to do here is this. I'm going to find, we are going to find each of these coefficients. This c is known as coefficient. Coefficient is any letter or number that is written in front of a variable. Like for instance, if I have 3x squared and I have ax squared, this 3 is a number, it's called coefficient. Coefficient. And this one is a letter. Because I'm writing it in front of this variable, it's still called coefficient. So the difference between these two is this. I can call this one arithmetic coefficient. I can call this one, because I don't know the value of the number, I can call it algebraic coefficient. Coefficient is simply any symbol or letter or number that is written in front of a variable. Like if I have something like this, if I have two variables, let's say I have two variables, let's say variable x, y, I have minus in front. Please, because this each of these is a variable, this is a variable, and this is another variable. I'm having two variables. So in this case, don't ever say x is the coefficient of y. No. What is in front of the two of them is minus. And anytime nothing is written in front of a letter in mathematics, we believe it is 1. So this expression I have is actually means minus 1 xy. So that means the coefficient here is minus 1 in this case. Please take note of that. We need all this idea so that we can follow what we are doing. Now, I want to generate what is called Maclaurin series. Maclaurin series. That means Maclaurin series is used to express any function f of x as the sum of the powers, as the sum of the increasing or decreasing power of terms in a given variable, such as variable x. What do I mean by that is this. I'm talking about a scenario whereby you can express this f of x as let's say 3x squared plus 7x minus 2x plus 3x squared plus 7x minus. You can see that there is a pattern I'm generating in putting up these terms. So addition of these terms in terms of either increasing power of variable s or decreasing power of variable x is what Maclaurin series is trying to achieve, and we normally use it to find the approximate value for the given function. Now let's quickly start our work. How do we generate Maclaurin series? This is how to generate it. We are going to find expression for each of the terms that I have here. Look at each of these terms that I have here. I want to find expression for them. For me to find expression for C0, I will take set x to be equal to 0. So that means anywhere I see x, I will put 0. And if I attempt to do that, I will discover that when I put x here to be 0, 0 times this will give, everything here will give us 0, leaving c0. So that means f of 0 is equal to c0. For me to get, this coefficient c1, c2, c3, and so on and so forth, I need to find the derivative of this function repeatedly. So let me repeat the derivative of this function. F prime of x, the derivative for, okay, please, this is how to find derivative. If you are given y is equal to ax squared, the derivative means y prime, and y prime means the y, the x. So you use the power, let's say raised to power n, use the power to multiply, then subtract 1 from that power. That's how to do, differentiation. So that's what I'm trying to do on each of these terms separately of the function f of x. So f prime of x, here, when you are differentiating a constant time, it becomes 0. So here now, if I differentiate this one now, it will give me c1, plus this one give me 2c2x, plus this one give me 3c3x squared, plus this one give me 4c4 x raised to power 3, plus and so on and so forth. Now, for me to get c1, I will set my x to be equal to 0. So x becomes 0. That means f prime of 0, everything, anytime the x becomes 0, everything here becomes 0. So that means my c1 will be f prime of 0. That will be my c1. To get other parameter, I will go back to the original function and find f prime prime of x. If I do that here, f prime prime of where I stop, f prime prime of this function that I have here, c1 will become 0, then this one will become 2c2, then plus this one becomes 2 times 3, that's 6 c3x, plus 3 times 4, that will give us 12c4 x raised to power 2, plus and so on and so forth. Now, when I want to get my c2, I will make x to become 0. So I will say let x become 0. When we set our x to become 0, I will now put 0 anywhere I see x. So that means f prime prime of 0 will now give us 2c2. Everything here becomes 0. So since I'm looking for c2, I will use this to divide this other side. So that means f prime prime of 0 divided by 2 is my c2. The same thing is what I'm going to do to get my c3. How do we do that? If you look at what I have here, I will differentiate where I stop here. That's giving me f prime 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 of x. When I differentiate this one gives me 0. When I differentiate this one gives me 6c3. Plus, when I differentiate this one gives me 2 times 12. That would be 24c4 raised to power x, because I'm using this formula to work out all this one. So in this case now, to get my c3, I set my x to be equal to 0. So I have f prime 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 of 0 is equal to c3. Then 0 times this one becomes 0. So I have this one. So therefore my c3 now will now become, we divide both sides by 6. So it becomes f prime 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 of 0 divided by 6. And this can be also be written as f prime 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 of 0 all over 3 factorial, because 3 factorial means 3 times 2 times 1. And this one too, I can rewrite it as f prime prime of 0 divided by 2 factorial. 2 factorial means 2 times 1. So this 3 factorial means 3 times 2 times 1, which is same thing as 6. Now if you look at this pattern very well, we discover that anytime you differentiate twice, what we'll have here will be 2. When you differentiate thrice, what we have here will be 3. So I can have a general formula for my binomial, Maclaurin expansion. So now let me write my final solution here. If you look at this one now, this particular polynomial can now be written in Maclaurin form by substituting all I have gotten. I have gotten c0 to be this. So I'll write it as f of 0. Then Then C1 have gotten it to be this. That is, I'll write plus f prime of 0, that's my C1, times x. Then plus, I have my C2 that I have here is f prime prime of 0 divided by 2, or 2 factorial. So I have f prime prime of 0, that is be x raised to power 2 all over 2 factorial, plus the next one will be, by substituting for the C3, will be f prime prime of 0, f prime prime of 0, x raised to power 3 all over 3 factorial, and the summation continue like that. And this expression is called Maclaurin's series. So this Maclaurin series can be written in a shorthand form as summation f nth derivative of 0, then x raised to power n all over n factorial. Now, I want to now write out the Taylor series from here. Taylor's series. When we want to form Taylor series from Maclaurin series, we set our 0 that I have here, set it to be the 0 that I have here, set it to be a, and the x that I have here, set it to be x minus a. So therefore our f of x in this case now will now become summation nth derivative. Instead of 0, put a. Then instead of x, put x minus a, everything raised to power n. Then all over n factorial. So, and then the summation start from n is equal to 0 to infinity. So that means the Taylor series can now be written out, by doing this counter. When the n is 0, I have this f of a, x minus a raised to power 0 all over 0 factorial, plus f prime a, x minus x minus a raised to power 1 all over 1 factorial, plus f prime prime of a, x minus a raised to power 2 all over 2 factorial. Then this thing continue into nth derivative of a, x minus a raised to power n all over n factorial. So I've been able to introduce these concepts of polynomial, and then by the expansion of the polynomial, I've been able to generate what is called Maclaurin series, and from Maclaurin series, I've been able to also introduce what is called Taylor series. I believe you have learned one or two things concerning my presentation. Please do not forget to like, subscribe, share my video with others. Have a nice day. Bye.